Just a brief introduction about Shiv. He has over 20 plus years experiences with databases. He founded MinervaDB and Chistadata Incorporation, which provides tailored database services for PostgreSQL, MySQL, MariaDB, and ClickHouse. He has served over 500 enterprises, including Fortune 500 companies, and recognized as a Microsoft Cloud influencer and keynote speaker in open source database field. Please welcome Mr. Shiv Iyer.
Hey, thank you. Good afternoon. Thank you so much, everyone in Nutanix who made this talk. And thank you, each one of you, for making a Saturday afternoon for my talk. So when I first started my conversation with Shiv, so we were talking like, okay, let's share a story about like how the journey in PostgreSQL performance engineering started with my life, and how do I address most of the problems even before starting MinervaDB, right? And now, if you look at like afternoon now, it's the third talk, right? So if I read over my slides, I don't know how many of you guys really will be connected. I'm sure. Like, so I don't want to bore you guys. So I start a quick introduction on like what is the core essence of my talk, right? So like I said, like I've been 20 years in open source database systems. Started with MySQL AB. So like I joined MySQL AB in 2002, right? So my job was like integrating InnoDB with MySQL AB. So 2002 till MySQL AB was all my ISAM, right? So my job was like how to get InnoDB to MySQL, right? So worked as a performance engineer till it got acquired by Oracle, Sun to Oracle, right? So I moved to Bay Area then. I was working for Twitter. So for me, it's like my job was how to make MySQL awesome for Twitter. Post that in Percona. From there, I started MinervaDB. Started the business in Bay Area. Oh, thank you. Okay. Right. So yeah, Percona to MinervaDB started in the Bay Area. Work for early customers were like Dropbox, Pinterest, Netflix, and then I joined with a larger data infrastructure engineering team of Yandex. Worked on SRE teams. ClickHouse happened, Chistadata, and recently now I'm in the MySQL influencer for Microsoft Azure, right? So that's pretty much back. For our open source and more than 500 companies. What brought me back was like Aadhaar, right? I was spending more of my time in Bay Area till I got an invitation to work on the Aadhaar project. Work a lot with the initial creators like Pramod and rest of the team, right? Then UPI. So the whole goal was like how to get a database infrastructure for the performance, scale, and reliability. That has been the core focus. And what is the talk today, right? So I want to talk about how the state of transaction relevance is influencing on your PostgreSQL infrastructure, right? So my talk has been like on multi-version concurrency control on the isolation level, and how to tune PostgreSQL so that your transactions are remaining optimal, right? So I'm not talking anything about infrastructure operations engineering across PostgreSQL. That's not my focus. Also, none of these things come as the recommendations of MinervaDB. So this is a whole is about how it has been experienced in performance engineering and troubleshooting in the PostgreSQL world, right? The most celebrated and least discussed, right? Today, when I talk to many of our customers, right, like 10 years back, right, when we used to talk about, hey, there is a database infrastructure performance bottleneck or challenge to fix, we spend more time in doing a detailed forensics of what is that specific set of transactions influencing it. Today, if you look at like, hey, I'm building a database infrastructure. I'm building it for horizontal scalability, which is good. I'm going to have many database instances. So I'm not really seriously worried about what's going to be the bottleneck specific to a transactions or set of transactions, because I'm already built to build a distributed database infrastructure. There are several companies solving it very gracefully, and it is very relevant from a technical standpoint, right? Like that's a way to look at, right? You have a larger data set. So how do you grow the data set? Is grow it horizontally, right? So it looks lean, operationally simple, reliable, no single point of failure for your database infrastructure, right? But now it is about the cost of the infrastructure you're building your database systems on, right? Like often, like when we get into engineering the database infrastructure, like PostgreSQL for performance, where do we start, right? We start from two sets. One is about building the PostgreSQL to accommodate your transaction infrastructure. Two is about how we are going to continue the infrastructure for the performance. Like if you're looking at like, I'm going to build a database infrastructure, ignoring the quality of the queries built or how it is being deployed, you could still solve the problem, right? This is about how the human beings healthcare work like, right? You can either treat the symptom or treat the disease, right? uh, so when you're looking at like, hey, I'm not going to look at my database engineering operations, I'm just going to add more number of boxes, and this is how I'm addressing the response time, SLAs, and the scale. It looks convincing for the end consumer, but then what's going to be the cost of the operations and the complexity, right? um, so what's the first rule? Like when you're getting into any time of performance troubleshooting engagement, right? So where are you in your transaction, right? So there are three stages your transactions can be in. Either they are in the process of transaction, there's this transaction inactive, or either it is blocked or the transaction crashed, in the sense the transaction corrupted, right? So understanding the transaction state. So how do we usually troubleshoot? So whenever we get a customer emergency support call, like, hey, there is a performance issue, we are facing a performance operations bottleneck. Help us to understand how do we start, right? At MinervaDB, we start with knowing the state of your PostgreSQL. At what state is your PostgreSQL, right? There can be seven major states for PostgreSQL transaction. It can be active. That's a usual one. That means that transaction is started, right? And it is in an active state, right? And if you see a transaction active, right? And then you look at like, okay, my transaction is active. Now it's taking longer time for the completion of transaction, right? So now my direction is towards why the transaction is going longer than the expected time. So every process, every transaction set, we will have a SLA to it. Now, when it goes longer than that, then your direction is towards identifying why that query is taking longer time, right? So you have got a direction to that. The next is rollback, right? So what means that your transaction started, then you don't know why it rolled back. So your direction for the diagnostics forensics of your PostgreSQL infrastructure is towards what caused the transaction to roll back, right? So now you look at the error log, you'll get into the slow log, you look at which is that specific transaction which rolled back, right? Now, idle means that the transaction begin, now nothing is happening, right? The next one is a prepared state. This is something which I would see quite often on a distributed PostgreSQL infrastructure, because as we all know that PostgreSQL support a two-phase commit mechanism, right? Whereas the transaction completed, but it's not committed, right? So typically on a very large cluster of PostgreSQL infrastructure, we often see that, hey, there is a latency, there is a severe performance issue, right? Now, when we see what is the state of your PostgreSQL, right? And when we get into the state that it's on a prepared state, that means that where do we need to look at? Is look at the cluster health of your PostgreSQL. Now you look at it, instead of troubleshooting PostgreSQL as a server, you are breaking out PostgreSQL to a different state it can be, right? And once you identify what state is currently in, then you narrow down, you make your entire troubleshooting quite narrow and specific, right? You are not troubleshooting the PostgreSQL as a whole server, right? The next state is it's committed. This is actually a good news, right? The transaction is completed. The next is like transaction block. And this is where we spend more time, right? When we know that a query is taking longer time, it's easy to troubleshoot. We just get into defining what is the current data access path, what's the execution plan. I look at how much my indexes are efficient, or what is the data distribution model within the PostgreSQL index leaf structures, right? Even I can even understand that what is the efficiency of my query. But in the transaction block statement, right, like there could be many reasons, right? The problem can be right from how you have built your PostgreSQL, right? PostgreSQL, like in our use case, like we have PostgreSQL in heavy transaction intensive systems. Like most of our PostgreSQL customers are either a fintech or very, very large SaaS companies. And for them, like when there is a block to the transaction, it starts right from what is your PostgreSQL configuration looking like. The next could be like, is there any specific query causing it? Third one is that, is there anything unplanned query operations happening? Let's see, like on a distributed database infrastructure, right? Imagine your proxy failed. Means your write nodes are also serving reads. Imagine a report instance, report application query infrastructure hits on your primary write PostgreSQL. What will happen, right? You see that suddenly there'll be a degradation happening. The reason because it's like you have more queries, reads hitting on the primary write operational infrastructure compared to the read replica, right? So if you look at when it is a transaction block, this can be the third skill. The fourth can be an infrastructure outage. 5, right? Like if you look at PostgreSQL 15 on Red Hat, if you have 4 update with outer joined queries, actually, right? Like you used to have out of memory errors, right? So there are many people who have been commented in the community. It's a build bug, all those issues, right? But then the point is that the query also influences, gives you a error log, which is also misleading, right? The seventh one is about failed. So what causes a transaction to fail? For me, the most complicated is one failed. The next is the block. The third one is rollback. The reason because it's not narrowing my troubleshooting, it's making it broad. Like I have to look at all the possible reasons, right from the build to the infrastructure. I need more evidences. I want to spend more time on it. But then if you can list down when you're troubleshooting, right, you can have the right audience in the room for the discussion. If it is a performance issue, if there is a latency issue, I'll have only engineering. But when it is a transaction block, I'll have a more bigger audience because it also involves understanding the capacity built up, what you build for your database. So what do you blame it on, right? Often, like all these things, you can blame it on one single reason, like how the multi-version concurrency control is built on PostgreSQL, right? It's actually good. That is about your building consistent data across your application infrastructure when it is used properly, right? But there is no rule of thumb to build a standard multi-version concurrency engineering for your PostgreSQL application, right? So this understanding 3 major things. 1 is about understanding your transaction. 2 is about understanding your infrastructure. 3 is about how do you use that database infrastructure, right? These are the major 3 points. And we need to look at like also the maintenance infrastructure operations, right? If you look at when you are working on a highly update intensive PostgreSQL infrastructure, right? You got to also understand that there are database infrastructure maintenance activities happening, right, on your PostgreSQL. Vacuum is one such thing. But then how are you managing it? Is it controlled or it is auto, right? If you are building an autonomous PostgreSQL infrastructure, you need to discount that the maintenance operations also influence on how the fundamental MVCC operations are going to look like, right? So, so the transaction management implementation in PostgreSQL is completely protecting your transaction state, building the systems, the transactions isolated and durable, right? So the transactions in a PostgreSQL is either on a commit or rollback statement, as I said, right? In a transaction blocks, the PostgreSQL spend all the transactions either on a beginning of the transactions, like it started, the transaction begin, or the next is like either it is like on an active state, the commit and the rollback one, right? There are multiple isolation levels supported in PostgreSQL, which is like read uncommitted, read committed. By the way, PostgreSQL don't have read uncommitted. In PostgreSQL, read uncommitted and read committed both are discounted as read committed. You have repeatable reads and serializable. So this leads to understanding how the data access phenomena influence on the performance of your database, right? So when you look at the concurrency, right, there can be only the 4 state of data concurrency matrices, right? Either it's one, it could be like you worry about the dirty reads happening. That means that your data is your data engineering queries are looking at the data which are not yet committed, right? What we call as a dirty reads happening there, right? And this can lead to inconsistent view of the data, right? The next is like non-repeatable reads, right? This happens when a transaction read the same row twice and find different data happening at a different time, right? The phantom reads, this happens when your transaction re-executes the query, it sees inconsistent data, right? And the write-write conflict happens when you have set a very aggressive kind of an isolation level. Like, everybody likes serializable when they want to protect the entire data transaction layer, right? They go for setting it serializable. But then what happened? The writers and readers start blocking each other, right? This is another major bottleneck to address. So if you look at how do you configure a database, influence on the performance, right? So like I said, read uncommitted is not supported, explicitly not supported in PostgreSQL. It's treated equally as a read committed one. And so the transaction see only the committed data before the transaction began, right? The read committed one, it's a default one in the PostgreSQL. And the repeatable reads, right? So you get to see all the time the snapshot of the actual query before the transaction has began, right? And this prevents the phantom reads. The serializable ones, right? This is the most strictest level of isolation where the transactions like protect both. It's like, at any given point of time, the transaction is being isolated, and it also protects the relevance of the transaction identity, where like the data remains the consistent across the query infrastructure. But this is only recommended when there is an absolute consistency is required. On a typical general ledger infrastructure, we are recommend using it, but this is should be very cautiously built. Okay, so when you look at read committed, which I start with read uncommitted and committed are same, right? Where the dirty reads are not allowed, but still you will have the issues like non-repeatable phantom reads and serialization anomalies. Whereas in read committed and you'll see on the repeatable read, you don't see the dirty reads and non-repeatable reads happening. In the case of serializable, right? Neither dirty reads, no repeatable reads, no phantom reads or any kind of anomalies will be detected. So now what we recommend, right? For most of your application, the read committed works great. When you're worried about a higher consistency without a significant locking, we recommend a repeatable read. We build only serialized database infrastructure on PostgreSQL in a state where we need a critical transaction isolation and serialized transaction engineering model. The statement level consistency is what we recommend for reporting. Like I said, right, like when you are building a distributed database infrastructure, you can't have a single isolation model for your entire transaction model, because you will have the insert intensive, you'll have query intensive, and you'll have a report intensive database, right? This is the benefit of building on a horizontally scalable PostgreSQL, because your proxy is taking care of routing the queries to appropriate database, right? When you have a report intensive one, you'll have a statement level consistency built. And the next is like how you can apply the locking hints so that you control the serialization model in your PostgreSQL infrastructure. So where you can explicitly build a locking model, like for example, for update, for no key update, or for share, or for key share. So you decide that what is going to be the explicit locking model for your PostgreSQL server, and based on that, you define the locking hints within your query. By the way, this can create the maximum number of trouble. You know why? Because people create this, and if they, by mistake, if they ignore rebuilding it, reallocating it to a different locking hint, this can block your entire forthcoming transactions in your PostgreSQL infrastructure. So how do we configure the PostgreSQL for the performance to reduce the blocking and deadlocks, right? Work memory. So this controls the amount of memory, you know, like how PostgreSQL is currently consuming for the internal sort operations. Be very careful about setting this value, because this is per sort operations variable. That means that it looks great for a smaller data set. If your PostgreSQL is growing bigger and bigger, setting it to a higher work memory can get you to out of memory errors in your PostgreSQL, because it's for per sort it's happening, right? Too low is definitely will be a performance bottleneck generator, because the frequent disk writes slow down the performance. But setting it too high is good if you know that how many transactions are happening in your database, right? So often we have seen that, hey, there is a performance bottleneck. When they start an application, they're like, hey, there's a performance bottleneck, increase work memory, right? That works great. But as the application grows bigger and bigger, then you see that this creates a bottleneck. This will be the root cause of your PostgreSQL outage. What we typically we recommend is that we can carefully look at monitor the transaction, and then increase it. We don't recommend more than 30%, though the documentation say 25 to 50%, but then we'll be very careful, because you have no control on the sort operation. Let's see that somebody go and write a very large query, or somebody does a select sort without a limit. What happens, right? That's sufficient enough to consume entire available RAM, right? So we'll be very cautious in setting this. The maintenance work memory. So maintenance work memory variable takes care of how the maintenance operation of PostgreSQL is going to look like. Again, the major consumers are during the vacuuming or the create indexing, or during the schema alterations, also in the key operations, right? Unlike this is, like this is for the server. For the work memory, if you look at it's set for per transaction, where this setting applies to the entire maintenance task, not per transaction. And so again, carefully set it if you are looking at a overall performance optimization of your PostgreSQL infrastructure. especially on the limited memory infrastructure. We again, as a rule of thumb, right? We don't set this value more than 50% of the available RAM. There are two kinds of PostgreSQL infrastructure. One is that PostgreSQL infrastructure used for a standard data operations, means that either you know that it's going to be insert intensive or it's going to be select intensive, right? But if you're looking at a database infrastructure where you have a combination of insert, update, delete operations happening continuously, so that means the maintenance operations on the PostgreSQL will be on a higher magnitude. So when you're building a PostgreSQL infrastructure where the transaction intensity is high with a heterogeneous transaction models, like what I said, the maintenance work memory plays a big role here, right? So looking after the careful observability is very important to set the maintenance work mem variable. Shared buffers. Again, setting shared buffers is very important if you're looking at your application performance. That is like how much the memory is allocated to your database server. This is to make sure that your reads are performing optimally, your response time is accepted, right? So again, don't set it too high. And like I said, like your continuous observation is very important here. Though people look at like ignore the hit rates, but then if there is a metrics exist in a PostgreSQL, then we look at like, okay, it's worth considering it. The reason because is that if you are looking at the disk seek rate is going high on a PostgreSQL, that means that we need to go back and look at the shared buffers. So the effective cache size, if you are building your PostgreSQL with several stored procedural programs, right? If your data logic is going to reside within your PostgreSQL, consider increasing your effective cache size so that your query performance will be optimal. The effective cache size. So overall performance of your PostgreSQL applications will be influenced by setting on the effective cache size. The next two variables, like which we spend a lot of time is, one is the deadlock time out, right? This is to specify the amount of time the system will wait before checking for the deadlocks, right? Default is 1 second. But then if you are sure that your application is built so that there will be minimal or no deadlock, keeping it 1 second will create an extra load in this machine, because the PostgreSQL server keeps checking every second for the queries which are the possible for the deadlock. So the max locks max locks per transaction. So this is defines the total number of locks for a single transaction can hold. This is very important variables what we are looking at managing PostgreSQL lock table, because it tracks all the locks happening to the system. The default system setting is too conservative if you have a very large transaction intensive PostgreSQL. So increasing this value can ensure that the transactions requiring a larger number of locks can complete successfully, but also this increase the memory consumption. So spend time in identifying from your monitoring PostgreSQL monitoring infrastructure that if your PostgreSQL queries are built optimal on a proper isolation model, then you can go with default max locks per transaction. So these are the scripts which is there on my GitHub. I often use. So these 12 scripts gives us pretty much the detailed information about troubleshooting the PostgreSQL when there is a block. If you're experiencing any deadlocks happening to your PostgreSQL. One is about identifying the long running queries in PostgreSQL. This is to find out the expensive queries by response time. The next is like if I find there are long-running PostgreSQL queries and in my transaction state they are blocked. So why are they blocked? So and how do I find out which are those transactions blocking? I use a query which for troubleshooting the transactions which are blocking in the PostgreSQL. The disk ops is to measure the throughput. And okay, so disk ops can be of two reasons, right? The disk ops due to the larger query sets, and also the disk ops due to delete. The disk operations during the deletes causes a transaction block, right? So we have a query only to find out what is the current state of the disk operations due to deletes. Um, the large sessions by the log time. We have also a deadlock detector queries, which I use it. Again, if I identified that my transactions are on a block state and I want to find out which are the queries, that's the query what we use for finding the list of queries waiting for a particular resource. I measure the average queue length of the query, and the session level activities query is what I find out. And I use it for finding out the state of my transaction in the PostgreSQL. For forecasting the infrastructure consumption, we use a linear regression query, which we use for troubleshooting the PostgreSQL CPU consumption. So, so it's a combination of one is about the matrices, two is about the queries, three is about the logs. This gives us the visibility to what's happening to the PostgreSQL server currently, right? So I just went faster because I'm happy to listen to your questions specific to the performance bottleneck due to the deadlocks, right? So
Okay, so please give it up for Shiv, guys.
hey.
Please. Now we can open it up for Q&A. Anyone has any questions? Please feel free.
Okay, I've got some good T-shirts, but I never knew how many people are there, so I just bought many of them. And but I don't know whether it, will be sufficient for all of you.
Maybe folks who ask a question to Shiv gives him the T-shirt.
Yeah,
We can't reconcile the sizes of the T-shirts, but yeah, if we have those sizes available, yeah. I mean, we have a few T-shirts, we have a lot of people, so we have to make some way to give it away. Or if you have a better idea, yeah. But yeah, questions, please. Yeah.
Yeah, hello.
Sure.
Yeah, here. So I just want to understand. See, I started my Postgres with RDS, so I don't know how the Postgres works on-prem. So will this apply to RDS? Because I haven't seen till now like doing maintenance on RDS. Because since I'm a beginner, I just want to understand your thoughts. Whether the same thing applies or like is it something different? I mean, you can take even Azure MySQL. Azure Postgres as well. The same thing.
It's actually a good question. Sorry, I didn't get your name. Rohit. Hey, so many of our customers, when they get into RDS, they say like, we are not seeing many of issues happening here, right? Maybe for a quarter or two, when they spend 6 months on PostgreSQL on RDS, right? As the database gets bigger and bigger, many of operational challenges are taken care in the RDS, right? But still, the cost of your query is very important. Let's see that when the database goes to RDS or Aurora, right? You are coming out of the all maintenance operations side of the query, right? But here we go out and make a very expensive PostgreSQL. Let's see your query is not built identifying what should be the transaction state, right? That means your query gets expensive, right? So the cost of your RDS bill will keep going high, right? So fundamentally, like with database as a service, the infrastructure operations, capacity planning, sizing is taken care from a procurement standpoint. But if you write an application without worrying about how the transaction exists within your application, so you create a very expensive database to operate and manage, right? Let's say you do an outer join on a foreign key column, right? And you have update happening to it. And when the data set gets bigger and bigger, what happens? Your latency will go high, right? You experience a deadlock, right? So you end up in adding more nodes thinking your application is getting scalable, right? The problem is how you handle the locks, right? This is like how the explicit locking is being implemented, right? Like for example, 4 updates, 4 lock no wait, 4 key locks, right? So if you consider these things in your building your database infrastructure, most of these challenges are taken care. So you can pick up the t-shirts.
So the 9th, yeah, here.
Hey.
Yeah, so that auditing, right? Auditing for the PostgreSQL system, it is the process level auditing, or it is for whole transaction, means like for whole database auditing, like the 9th.
Sorry, I didn't get your name.
Amrit.
Amit. Hey, so this is, like when you're doing a troubleshooting, right? That's when I say that understand what state is your PostgreSQL currently in, right? When you're auditing for performance, right? When you're auditing for the query quality improvement, right? When I say my query is active for a longer time, that means my auditing is biased to understanding what is the cost of the query, right? I look at explaining the query. I look at like what is the data access path, how is the index efficiency. Now you look at completely to a block session, right? Then I don't look at explaining the query first as an option. I want to know that where is the block, where is the wait event, right? It's like, for example, I travel like all the way from Whitefield to this office, right? There could be only 2 reasons I can be late. The one is that my car is not fast enough to reach here in 20 minutes, right? 2, my car is too good to reach here in 15 minutes, but there are a lot of traffic jams, right? So the wait part of the query, right? Where is it waiting? Is it waiting on the server, or is it waiting on the infrastructure? Is it waiting on the resource, right? Who is blocking who, right? This is like in a typical large PostgreSQL infrastructure where you have a larger update queries, right? So if you are not explicitly handling the transaction identity or the isolation level, right? So this creates an additional weights, right? So this will direct. So typical auditing for me involves about understanding the infrastructure, understanding the query construct, understanding the index efficiency, understanding all the wait events. Every query, for that sense, there'll be a wait event happening. But then when that wait is not to the accepted value, that's when it becomes a concern, correct? So
no, but it helps you to like the 11th, right? There is a forecast for the CPU throttling. So
right.
So you take the parameter of the previous steps and then you analyze, or because like 12 factors you considered for entire.
Right. So this is actually my. So we normally get. There are 2 ways, right? As a database infrastructure service provider, right? One will be a planned performance audit. There we'll have more than 100 matrices. This is a emergency support one. So we get not more than 3 to 4 hours to troubleshoot and fix it. So we need to get as much as data which is relevant, right? So we get up this. If you look at the linear regression model, query has been built to understand the capacity planning sizing. So again, right, your query can be optimal, but your infrastructure is not built for this query operation. So as we know that we always revisit on the infrastructure of the PostgreSQL, right? So
hi Shiv, nice talk.
Yeah.
Sorry. Yeah.
Hi. Yeah.
Hi Shiv, nice talk. So I have a little bit experience in my SQL and Postgres, and like more in MongoDB. So since MongoDB is no SQL, so regarding with this performance optimization, what all things we should consider while considering transition from Postgres, like from SQL databases to NoSQL databases?
I'm sorry.
What I mean to ask is like, I have more experience in MongoDB. So with your experience in SQL databases, what all points we should consider when we have to solve this problem of optimization of queries in NoSQL databases?
Good question.
And
all right.
And sorry to interrupt. And why this is relevant, because I just started working at a fintech, and we had like memory issues with the server AWS servers because we wrote unoptimized codes for MongoDB, and that had took so much of memory, and that crashed the servers multiple times.
Good question. Right. I tell you, all these RDBMSs, right? They never built for handling larger data sets. So is anybody in this room is there with more than 500 terabytes of PostgreSQL, one server? 400, 300, 200, 100, how much? 200, one server. What is your biggest pain there? When is your biggest pain?
Query, catch performance, tuning, all that.
The query operation, is it a
But-
select or what is that query?
No, mix, maximize,
Okay.
update.
So- Right. And was this there when it was 50 terabytes? That problem was existing?
No.
Right. So when you have a larger data sets, right, that's when the problem begins, right? So as the data get bigger and bigger, you have this problem about latency, throughput. So what's the fastest way to troubleshoot a database? Partition it. So if you look at the fast, like if we find out during a performance audit, there is no deadlock or blocks or wait events happening, and still the user is actually having an issue. Even after observing the execution plan is optimum, index usage is perfect, right? So what we do, partition it, right? Identify that table which has the larger data sets, right? And identify what is the data distribution. Could be by city or gender or the item types, everything, right? Identify that category, partition it, right? So that leads to the point that the SQL systems always will have the data size limitation. Now, the next to that is that when you're building a database infrastructure, right? We talk always about the query performance, that is the select query performance. What about the inserts? Right, the inserts are even a larger problem to solve, right? Thanks to we have many write scale PostgreSQL today, right? But then when you're looking at building a PostgreSQL for the insert performance, right? We often see that if you are an insert intent system, right? Do you really need to worry about deadlock timeout? No, right? You're an insert. What's a deadlock, right? So you don't need to make it very aggressive, right? And also the max locks per transaction, right? So look at like how your PostgreSQL will look like from a configuration standpoint, right? Like unless you need it, don't go for it. And too much is not too good, right? Like for example, like I've seen people using like workmem as high as possible. It's good if they have a control on the transaction. But when you said that you come from a Mongo background and looking at here, right? Definitely are looking at transaction volume size is much higher, right? So you need to look at very carefully about how your transaction will look like within your PostgreSQL, right? So this leads to actually the first deck, know what is the state of your PostgreSQL. So benchmark your PostgreSQL, try at least like 40% close to the actual transaction behavior. And then you see that what it looks like, right? And from there, you focus your build. Thank you.
Hi, Shiv. I have
Yeah.
a question. Like during scale events, how do you handle performance loss occurring due to auto vacuum or like dynamic vacuum strategies? So, for example, you have a flash sale going on and you have lots of queries, both optimized and unoptimized, badging at the database. And obviously, you don't have enough time to go ahead and optimize everything. You know where the shortfalls are, which are the long running queries, but they still need to run and auto vacuum takes place at that time. So what would be a good strategy? Like there are many ways to do it, but
Sorry, I lost you there.
How would you like deal with auto vacuum at that point in time? Like what would be your strategy to ensure that auto vacuum does not lead to performance loss during a scale event?
Okay. So if I understand, you're like, how do I understand to optimize my PostgreSQL more proactively, right? Very good question, right? It's also a very difficult question to answer. I tell you why. You can never define what's going to be the data volume growth of your PostgreSQL, right? Like I was a guy who built one of our largest ad aggregator platform, right? The number of data sets identified initially, that means the table when we built it, right? It had fewer categories when we built it to when it went to production in few months, right? So if you look at My original idea was to build a table dedicated for the writes optimally, right? But over a period of time, I found that this table is going to be also going to be an update intensive, right? So I just went on a default read committed model, right? I never discounted for the phantom reads happening there. Means that there is going to be a transaction or data inconsistency on the queries. That means that few of the transactions, when it updates, the whole meaning will change. The two data sets will have two different meanings from two different queries on two different transaction standpoint. My customer had a bigger problem. Technically, for me, it was looking like a smaller problem to fix. For a customer, it was like, as you said, like from a business perspective, the database was not working, right? In such scenarios, if you really look at like one, invest on a good PostgreSQL monitoring infrastructure. I'm not saying about invest on a proprietary one, open source. No, always understand that how do you continuously monitor this. This could be even a normal select. By the way, PostgreSQL's the dynamic data dictionary views have become more smarter with the rebuild or build, right? Know which state is your PostgreSQL spending every 24 hours. So I always will have the data about what is my state of PostgreSQL. If it is active, I look at always spending time more with SQL engineers. But if it is rollbacks happen quite often, right? If a rollback is a rule of thumb, right? Maybe more than like 3 or 4 every 2 hours happening. That means that there is a severe flaw happening on how the locks are implemented. Being idle is fine. On the prepared state, I look at like what is my cluster health. The larger PostgreSQL cluster is a different problem to solve. If my PostgreSQL is on a prepared state, even if my queries are looking optimal, being on a prepared state for a longer time too frequently is a point I will worry about tuning my PostgreSQL clustering. Transaction block and failed. So why is it failing? I look at it, and if I'm seeing the blocks happening, then I look at like how to identify why it's blocking too frequent. Then in that case, what I do is that we have a very good utility which we use it. Monitoring PostgreSQL thread performance. This Python scripts which I have in mind. This helps me to find out it, and also about the detailed forensics of my query operations. So. Sure. Mike.
From the log, it can read the sequence where it got fed in. Again, it will start from the retry, and then transition can complete. Kind of security or something is there.
Yeah, that'll be good. So if a transaction fails, is there any way I can build a self-healing PostgreSQL which realizes the failure and alert it and restart it, right? Good question, right? The transaction tolerance, mostly we build it within the application, right? Like within, always we configure PostgreSQL to report failure as frequent as possible. The reason, because we need to do the root cause analysis, because self-healing systems also come with a cost, right? I missed what is the epicenter, right? Maybe it's self-healed, business is not impacted because the throughput is low. Now multiply this into 10x, right? Then that means that I'll have a bigger problem to solve. So first question, is it possible I can do it? How do I do it? I'll implement it on the application level, right? I look at like what is the cause of the failure. If the failure is because of a wait event or wait for the resource actually, right? Then I look at like what is the isolation level set for that query, right? Not all the queries need to be on a repeatable read, right? We have the similar issues happening. The queries on the repeatable read demands for a more stricter way of isolation, right? The concurrency model handling, right? So we move it to repeatable read so that this is addressed it. But also this leads to the state that how the query is constructed. So most of the queries which fails, we qualify them as the query which needs an explicit locking, right? We need to handle the locking within the PostgreSQL, right? Not outside the PostgreSQL.
Thank you.
Sure.
Hi Shiv, a great session. So actually, a couple of years back, I was stuck in a similar performance like troubleshooting in production database, but it was a SQL server. So I would like to know from you, what is the worst performance issue that you have faced all in your like 2 decades plus career? It'll be interesting to know. Thank you.
The worst experience I ever had was on a PostgreSQL infrastructure. I'm talking on a PostgreSQL infrastructure, right? One of a consumer-facing internet application provider, right, use PostgreSQL, and they had extreme reads, and they had both reads and writes happening to their database, right? Which is fair, like, you know, like we configured the shared memory and all optimal. They had a very good one. They decided to go with a synchronous replication, right? And one guy went ahead and just wrote an update on a larger data set. The entire database froze. Now, when I go to the state of PostgreSQL, it says that it's on an active state. It's on a 2-phase state commit happening actually, right? So, and I have no data to come in. I have no data to look at, right? And unfortunately, customer never had a monitoring stack. So I don't know what is happening. So I have to just wait, right? Luckily, what I did was that I could find out which are the fast growing tables, right? I could see that few of the tables which are growing very fast, right? And then my diagnostics narrow down to finding where is that query coming from, right? The top sessions. Then I could find out from where what SQL has been triggered, right? Then I could find out the update was happening. This is another very good question. The reason because when you're building a synchronous replication, this is something like even in PostgreSQL and MySQL world, everybody wants a synchronous replication. But is everyone qualified for a synchronous replication is a big thing, right? If you're going to have only the writes, no updates, no deletes, synchronous replication is awesome. But the moment if you're having an updates, deletes happening, then across the cluster, right? Because it's everything or nothing, right? The clustered system consider as how many cluster you have is a single instance, right? And if a transaction triggers the wait, it is a wait across the cluster, right? So this was a harder problem for me to solve. 15 had I don't know how many committers are there in this room. I mean, I came late, sorry. So 15 had out of memory error. 15.1.3 had out of memory error, right? Yeah. So out of memory error, it happens on the fetch across commit, right? A query which runs as a background process which keep fetching across every commit had this issue. And that was another problem actually. Then the problem was in the optimizer actually. So on the Dyna compiler was the issue actually. So yeah, that's it.
Hello. Yeah, I'm Sakshi.
Hey,
so
Sakshi.
my question is, how do we manage read-intensive database? We have moved from MySQL to PostgreSQL due to application dependency. It was a preference. It's basically a medical application that is used by clinics, hospitals to see the treatments. So basically, it's more read-intensive applications. And we have moved from MySQL to PostgreSQL. And if the requirement satisfies, otherwise we have to move to NoSQL. So
have you already moved?
Not for some of the microservices. Some are still in monolithic architecture. So those still are in monolithic. We have moved from MySQL to PostgreSQL.
Okay.
These are
self-managed PostgreSQL, is it?
Yes, self-managed.
Okay. How big is your database? Okay.
I'm
you have a lot of deletes.
responsible to manage the database, upgrade it, write the SQL like write the liquid-based scripts, these things.
All right. So the last 5 years, whichever PostgreSQL instances I manage, right? I invest on a very good monitoring infrastructure. But that said, I never stay away from troubleshooting PostgreSQL within PostgreSQL. Means that I very
Steve actually has to head off. He's being really humble. So let's take maybe a couple more questions.
I can take I can take 2-3 more. Yeah.
You want to have food here and then run for the meeting, right?
That's okay.
Okay, sure. Okay, 2-3 more questions. And then what we will do is we have a Slido link so people can ask their questions there and it'll send the questions to you, right? Sure. And while Shiv is here, obviously you can connect with him. Yeah, you want to use this?
Okay. Thank you. Okay, so I invest on a good monitoring. Monitoring begins there. But that said, that like I also look at understanding or using the methods which helps me to know the state of PostgreSQL. Like no monitoring script will shows me that what is the data access path. They show the execution plan. The data access path, I will find out that, right? Especially when you're somebody who moves from MySQL to PostgreSQL, right? MySQL is made for read intense operations, right? Whereas PostgreSQL does that, but not as graceful as MySQL. So I will look at two aspects. The data sets of my schema on PostgreSQL will be leaner compared to one on the MySQL. Like I'll have a leaner data set. So I'll invest on a good horizontal and vertical partitioning sets. Two is that I look at on the wait timeout parameters, especially, like how I can handle the wait events one. The third important aspect is that any new application, I will handle the locking explicitly because I never know, right? So yeah. Over-indexing is a problem in PostgreSQL. Over-indexing is never a problem in MySQL. If you compare it, you'll see that, right? So,
hey Shiv.
Yeah, hi.
You were talking about whenever your data scales,
okay,
you should horizontally scale it. Could you explain that statement? I couldn't understand what.
I'm sorry.
You were saying like whenever your data scales, you should horizontally scale it. You were saying something similar. I couldn't understand that statement.
Yeah, like when you, let's say a table. The table is like every database system. Take like, the 80-20 principles we apply in the business and in the day life, right? Every database will have less than 20% of the tables which are very big in size. And the remaining ones won't be the epicenter of problem. The epicenter of problem is all those large tables, right? Now, so being large is the problem, right? So break that large into smaller ones, right? So I will have the smaller data sets to make sure that my database look leaner. My schema objects looks leaner, right? The next part is that if you have a disproportionate distribution of reads and writes, say that 1% of the time is spent on the writes and 99% is on reads, then my read should not be hitting on my writes database, right? So in such scenarios, like I consider having the reads outside the writes, right? So here I am, so moment my reads are going outside my writes have become very scalable because that server is only for writes. Like I'll have if it is a non-sequential data access model, something like a time series 1, right? So in such data sets, I will use even threaded writes, like multi-threaded write operations in PostgreSQL.
Yeah, hi.
Yeah, hi.
So currently we are undergoing like Oracle to Postgres migration.
Wow. Okay.
So without any tools as of now.
Okay.
So export and import is what we are just going. You have any other methods which can help us? And that's my first question.
Okay.
And the second one is about the auto vacuum process.
Yeah.
So there was a scenario where the vacuum ran and the whole of production was on a halt until that completes. So how can we get back to the production within a shorter time? So these are.
There are a lot of stored procedures in Oracle?
Yes.
PL SQL?
Yes.
Okay. So it has to happen in 3 sets. One is about schema mapping, right? How the schema structure looks on Oracle is entirely different to in PostgreSQL, right? So schema mapping to data type compatibility, right? This is very important because the objective is not to build a very big PostgreSQL, right? the bigger the PostgreSQL, right, the expensive will be your vacuuming operations, right? The vacuuming, when it goes autonomous vacuuming, you're saying PostgreSQL that, hey, just whenever you find there is a need for the vacuuming, right, start trigger for that, right? And now if you don't invest on the schema mapping, that means that your PostgreSQL will have continuous auto vacuum triggered on an autonomous vacuuming. Point number one, I will be investing on the schema set mapping. Stored procedures, I spend again, how I can get them optimized for PLPG SQL 1, right? Or I use even a proxy which can understand the wire protocol implementation in stored procedure. We have one of the large customers who was on Oracle. It's a bank, moved to PostgreSQL. When they try to rewrite everything on PostgreSQL, PG SQL, it becomes a very expensive task actually. So what they did, they built a proxy. So we built a proxy for them, which is Oracle PostgreSQL wire protocol aware for the PostgreSQL. So the proxy took care of the semantics conversion. But autonomous vacuuming is good to have, but then very cautious and very speculative investment, because you never know, right? Like somebody just go, you have no control. Like I'm sure, how many of your DBAs in this room? I think majority are DBAs, right? And you have no control in your database. Somebody can just go and change the structure from the engineering, right? So auto vacuuming is yes for me only if I own the entire database. No, if I have no control on the database schema, especially on a multi-tenant database architecture, I'll be very careful.
Okay. How about the synonyms? We used to have a lot of synonyms in Oracle. So how we are getting to Postgres? Is there like, yes, we are using some views, but is there any other methods?
We have used temporary tables.
Temporary tables.
Yeah.
Okay.
Thanks to PostgreSQL 16, I think PostgreSQL 16 has implemented temporary tables more gracefully. I have the build of it. I can share with you that. Just send a test mail. I'll be able to send you that. We have created an extension for that.
So some people have been asking me about food. It's really late. I'm sorry. Food is available. So you can head over, take whatever snacks is available, and if you want to sort of ask more questions, you can ask while Shiv is there, or just put it on the link that's available on that QR. So just scan the QR. You'll get to Slido, ask your question there. I'll make sure, as far as I can, to get your questions answered and posted it in the LinkedIn group for Postgres Bangalore, right? Just put your questions there, or if you put your name or email ID there, I'll get it relayed to you. Right? So yeah, please head over food if you want to. If you want to talk to Shiv, Shiv is available for a bit. So go for your questions.
Sure. Shiv, one more question. So you talked about your early career. You started with MySQL and you've been working on MySQL for quite some time. What made you move from MySQL to Postgres and bringing in MinervaDB? More of a personal question, maybe.
No, I mean, as an open source guy, actually, MySQL brought me because of InnoDB. So I was in InnoDB. PostgreSQL brought me because, like the need is same, the topic, the transaction completion, right? Like MySQL is not built for the transaction build, like how Postgres is built, right? Like for example, explicit locking in MySQL is a very expensive thing to do. So PostgreSQL was solving some of the requirements which I had on the customer front. So today, like I've been with PostgreSQL for more than 13 years now. So both, I'm in both actually.
Hi. Can you hear me?
Yeah, I can.
So my name is Manoj. I work as an infrastructure architect.
Oh yeah, hi Manoj.
So somewhere around 10 years back, we were using MySQL as our database for doing an analytical processing. So our database used to run at that particular point in time somewhere around 400 GB, 300 GB. We had an entire data set of around 400 GB we used to process. For reasons beyond my paycheck, we migrated into MariaDB rather than MySQL. But we found that MariaDB works fine for analytical processing, while I think PostgreSQL has issues. That's what I come to know about it. Is there a way to containerize Postgres SQL? One. Second question is, what sort of tools do you use for performance tuning as well as monitoring?
Okay, good question. For monitoring, we have our own custom extensions for Grafana. I can send you that, what we use in the customers, right? I'm still a old school guy who's a lot of scripts, several scripts, right? Now, from a performance standpoint, right? Like the build what you do for a OLAP system is completely different from what you build for your OLTP system, right? So this involves how your schema structure look like, how is the query distribution look like, what is the wrapper quality you are using, like so it's a combination of everything. So look at like this, like I want to have the indexes built for the query. Unless you find that indexing is not influencing on the optimizer on the execution plan, don't go for it. Because if you see, your lab systems also ingest a lot of data, right? And everything on PostgreSQL is expensive because, like the vacuuming process, right? Like you do it, PostgreSQL do it, but that is bound to happen, right? If you look at in MySQL, we don't have such process, right? Like MySQL leaves as is, like whereas in PostgreSQL have this maintenance, right? The another part is like be aware of the multi-version concurrency control implemented, right? If you are building an OLAP where if you look at the reference value schema checks are very high, means that you will always have the differential checks happening to multiple schema objects, right? Then your query quality is very important, right? Like, so discount all these things, then you will come to an answer.
Links.
I can. Just write to ceo@minervadb.com. Just give a short, this one description of the problem. I'm happy to talk to you.
Thank you.
Thanks, man.
So one of the problems we are facing, right, whenever we are using any sort of transactional systems, because of the entire microservice-based architecture, the use case for distributed transaction always comes up, right? So is that being solved from a DB point of view right now in any of these databases, or that is something it's like outside problem as of now?
Look, on a microservices architecture on DB, the bigger problem to solve is how the thread operations looks like for your Postgre, right? Like how's your thread pool is been handling, what's the thread caching mechanism, right? Because the contention due to the threads, right, from the individual services is beyond your control, right? So that means that how are you handling? I'm very sure if you look at, you'll have many idle sessions on the PostgreSQL, right? So that means that you should have a timeout built in a way that the idle sessions are not going to be encouraged beyond a point of time, right? So careful evaluation, right? Like you will see, so this is thing, right? People say that you made a forced timeout that made few of my terminals timeout, but then that's an isolated issue, right? Like no databases, trust me, even in Twitter, be it in PayPal, be it in Garmin, wherever, whichever places I've worked, there are victims of forced termination of the sessions. That's bound to happen. If you leave it uncontrolled, the whole database will come down. This is only the process get impacted, right? So
thank you.
Thanks, man.
Once, you can have some food.
You had a question, right? Yeah. Need a mic.